let us take two events only, E1, E2, are two mutually exclusive and exhaustive. I have given all these things in the first class of probability. Mutual exclusive means no common path, that is intersection is equal to 5. Exhaustive means union becomes sample space. Okay, that is the events are said to be exhaustive means all the events include the total outcomes of the sample space. So mutual exclusive and exhaustive means that if I take two events only in that experiment, E1, E2, E1 union E2 is equal to E1 union E2 is equal to sample space S, and E1 intersection E2 is equal to 5. Okay, that is the meaning of mutual exclusive and exhaustive. And A is any event in the sample space. That is, we will identify or we will assume that A event, arbitrary event in the problem only. Okay, A is any arbitrary event of S. Then the conditional probability of E1 or E2, I is equal to 1, 2. If I take two events E1, E2, EI given A, general letter is EI, but I is equal to 1, 2, 3, that is E1 given A, E2 given A, E3 given A, so on. So that tells that conditional probability P of EI given A. Okay, P of EI, that is numerator probability multiplied by reciprocal. This reciprocal, what is reciprocal? Interchanging numerator and denominator. That is EI given A, reciprocal becomes A given EI. So this is came by that P of A intersection B multiplication theorem and conditional probability only, and divided by summation I is equal to 1 to n, this term. What is summation I is equal to 1 to n? Just expand by giving 1 by 1 value to I. You will be getting sum of all events. That's why it is total probability. E1 is there, E2 is there, En there, A is also there. That's why it is called total probability. The denominator of Bayes theorem is called total probability. Now, how you identify from a problem P of A is useful or P of EI given A is to be needed? From the given problem, how we identify, that is to need or to calculate P of A or P of EI given A. I is equal to 1 to n. Okay, so I will give the one example. Three boxes are there. The three boxes let us denote by E1, E2, E3. In the three boxes there are two red balls and three green balls, two color balls, two red, two green, two red, three green, one red, one green, like that. Okay, now a box is selected and pick a green ball, pick a red ball or green ball, okay, from the box. Then my question is, what is the probability that the picked red ball or picked drawn red ball, drawn green ball came by box 2? That is mentioned, came by box 2. Box 2 already we selected. Again we are going back. That is the ball already drawn happened, but it is asking came by box 2. So that is called P of E2 given A, because we denoted box 2 is E2, box 1 E1, box 3 E3, like that. What is event A? Getting or drawing a red ball or green ball depending on the question or problem. Okay, so this is nothing but going back, past tense, Bayes theorem. That is, this Bayes theorem is useful for finding inverse reciprocal probability. Reciprocal means going back. Okay, like that. So I will show you one example, then easy to understand this theorem. Just one example. We are given three boxes or three bags as follows. Box 1 contain 3 red and 5 white balls, comma. Box 2 contains 2 red and 1 white ball, comma. Box 3 contains 2 red and 3 white balls. Full stop. A box is selected at random and a ball is drawn from the box full stop. If the ball is red, comma, what is the probability that it came from box 2? Question mark. See, let us denote the 3 boxes. Let E1, E2, E3 basic events, okay, be denote that boxes 1, 2, 3 respectively, okay, be selected. Then, because 3 boxes, each box selecting a box, each box is equally chance, having same chance. Then, P of E1 is equal to P of E2 is equal to P of E3 is equal to 1 by 3. Okay. Now in the second stage, so in this problem and conditional probability in this chapter, that you properly assign the letters events E1, E2 or A, B letters according to the sentences available in the given problem. Properly you take the sentences of the given problem and denoted by E1, E2 or A, B, C events like that. Okay, that is very important. Let A is equal to, this is arbitrary event. Okay. So after selecting a box, what he has done? Pick a red ball. Okay. That is, a box is selected and a ball is drawn from the box. Drawing a red ball. Why I am taking drawing a red ball? Because if the ball is red is mentioned. Okay. Then you have to find P of A given E1. What is the meaning of this sentence? Conditional probability. First denominator happened. Then numerator is going to happen next. So what is denominator E1? That is box 1 selected. In the selected box, we draw a red ball. So how many balls in the box? First box, 3 red and 5 white balls. But we are picking only 1 red ball. So 3 red balls, 1 red ball picking means 3C1. 8 total balls, 1 ball picking means 8C1. Here I am writing total balls in box 1 is equal to 3 plus 5, 8. Total balls in box 2 is equal to 2 plus 1 is equal to 3. And total balls in box 3 is equal to 2 plus 3, 5. Okay. And we have to find P of A given E2. Suppose if second box is selected and then again pick a red ball. In second box, total balls 3, out of which 2 red balls. So 1 red ball picking from a second box, drawing 1 red ball drawing from a second box in how many ways? I mean, the probability is 2C1 by 3C1. That is 2 by 3 this is, and here this is 3 by 8. And third box is there. P of A given E3. What is the meaning of this sentence? First select a third box and then pick a red ball. So in the third box, total balls is equal to 5. There are 2 red balls. One red ball can be picked from the third box after taken 2C1 by 5C1. That is 2 by 5. Then finally, what is the question asking? What is the probability that it came from box 2? That means here what happened in this stage? Box selected happened and ball is also drawn happened. Ball is also taken. Okay. But that compulsory drawn ball is asking came by box 2. That is again we are going back. Box 2 is denoted by E2. Drawn red ball denoted by A. So going back means reciprocal. That means P of E2 given A. That value is obtained by the previous theorem, that is Bayes theorem only. Okay. Therefore, probability that drawn red ball came by box 2 is nothing but reverse way. E2 given A. Here drawn red ball happened now. Okay, already happened. That is, please keep that corresponding letter in the denominator. That means this probability is concentrating on which sentence? Box 2 came by box 2. That means box 2 keep in the numerator. Box 2 is denoted by E2. That is reciprocal, going back. Okay. So using Bayes theorem, how much this one? First numerator, probability of the numerator multiplied by the reciprocal event of this E2 given A. That is A given E2. Denominator P of E1 into P of A given E1 plus P of E2 into P of A given E2. That is sigma I is equal to 1 to 3 plus P of E3 into P of A given E3. So in all these pre-multiplications are common. 1 by 3 is cancelled. P of A given E2 we got 2 by 3 and this is 3 by 8 plus 2 by 3 and this is 2 by 5. So after taking LCM and simplifies to 80 by 173. Later you check. The answer for this 80 by 173 after cancelled all 1 by 3s in NR and DR, numerator and denominator. Just I have given the reason total balls in each box and which ball we have drawn, that is cleared, that sentence A. And from each box, after selecting each box, we have drawn a red ball, that is second stage. Third stage is going back using Bayes theorem, came by box 2. 3 stages here. Stage 1 is selecting a box, stage 2 is picking a red ball from that box, stage 3 is that compulsory drawn ball going back, that is came by box 1 or box 2, that is we are reciprocaling that event. So one or two problems I am going to do on this. (2009) 2 marks. A screening test is carried out to detect a certain disease. It is found that %12 of the positive reports and 15% of the negative reports are incorrect. Full stop. Assuming that the probability of a person getting a positive report is 0.01, comma, the probability that a person tested gets an incorrect report is now here two types of reports, positive reports, negative reports. Let us denote the events by E1, E2. Okay, so after tested that reports are positive reports or negative reports are incorrect also it is given. Okay, solution. In the first stage, let E1 comma E2 be denote that positive comma negative reports respectively. That a person get positive comma negative reports respectively. Then probability of getting a positive report is given 0.1. Automatically other report, if it is not positive, the report must be negative only. So positive report plus negative report, only two cases, their probability is always, sum of the probability is always 1. So it is nothing but 1 minus 0.1, this is 0.99. One of this is given, it is sufficient. Okay, not required to give both. Next, in the second stage, let A be the event that the report is incorrect. That is, the person tested to get the person tested and then getting the report is incorrect. Then, so that incorrect report, the person gets tested and he got the incorrect report. That incorrect report came by come from either positive report or come from either negative report. So using conditional probability, this is P of A given E1. What is the meaning of P of A given E1? After getting the positive report, that is E1 is positive report, A is incorrect report. That incorrect report comes from positive report. Okay, which is given 12%. Okay, so that is 0.12. What is P of A given E2? That the person tested and it gives incorrect report from negative, which is given 15%. That is 0.15. That is 15% of the negative reports are incorrect. Okay. So what is A given E1? That the incorrect report is positive, that the incorrect report is from negative. Okay. And what the finally required? Therefore, probability gets an incorrect report, which is denoted by event A. So using total probability, that is denominator of the Bayes theorem, P of E1 into P of A given E1 plus P of E2 into P of A given E2. That is probability of a positive report and then incorrect report from positive. Select a negative report and then an incorrect report from negative reports multiplied. Okay. So this is 0.1 into 0.12 plus 0.99 into 0.15. Simplify. Sorry, here I have done a small mistake. Probability of positive report is 0.01. So it gives negative report 0.99. So here 0.01. And this simplifies to 0.1497 approximately. Next. This is 2006. Later you do. I will explain along with the answer. 3 companies X, Y and Z supply computers to a university. The percentage of computers supplied by them and probability of those being defective are tabulated below. Company percentage of computer supplied probability of being defective. X, Y, Z. 3 companies. 60%, 30%, 10%. 0.01, 0.02, 0.03. Given that a computer is defective, comma, the probability it was supplied by Y. Answer is 0.4. Okay. So hints I am giving: E1, E2, E3. Okay. X, Y, Z company. Okay. A event defective. Okay. Now what we require here? P of E2 given A. Okay, P of E2 into P of A given E2 divided by P of A. What is P of A? Bayes theorem. Using Bayes theorem, that is denominator. I am not writing I is equal to 1, 2, 3, all these things. Okay, just with this hints and that answer you please check. So this is P of E1, P of E2, P of E3. This is P of A given E1, P of A given E2, P of A given E3. Probability that the computer being defective, the defective by company X or company Y or company Z. That is the meaning. And finally, what the question required? The probability that the defective computer manufactured by company Y, okay, came by, supplied by Y. Going back to reciprocal, that is called Bayes theorem, P of E2 given A. Okay. This is Bayes theorem only. The next one is 2005, 2 marks given. A fair coin is tossed 3 times in succession. Full stop. if first toss produces a head, then the probability of getting exactly 2 heads in 3 tosses, is. So here a coin is tossed 3 times. That is also given that is also given as 3 coins tossed one time at a time. Okay. First toss, first coin compulsory shows head. Then we require the probability of getting exactly 2 heads in 3 tosses. So since first toss produces a head, sample space S is equal to, first is H, next one is HH. Out of all 8 outcomes, I am considering only these HHT, HTH, HTT. Why I am considering out of 8 these 4 only? Because first place, first coin shows compulsory head only. Okay. Let event A is equal to getting exactly two heads. So in that sample space 4 outcomes, how many outcomes containing exactly 2 heads? HHT, HTH. So therefore P of A is equal to 2 favorable cases, total cases 1/2. Answer. Simple problem. Next one is definition of odds. Odds is the ratio that compares the number of favorable outcomes of an event to the number of unfavorable outcomes. This is the definition of odds. Next, if E is an event of a sample space S, then 1. Odds in favor of E are defined as P of E ratio P of E bar. Second one, odds against of E are defined as P of E bar ratio P of E. So there are two types of odd, in favor and against. Okay, odds in favor of E are defined as P of E ratio P of E bar. Odds against E defined as P of E bar ratio P of E. Okay. So one example, an odd in favor of hitting a target by a person is 3 to 5, and the odd against an event of another person hitting the target is 3 to 2. Full stop. If each of them fire once at the target, comma, find the probability that one, both of them hits the target. 2, at least one of them hits the target. 3, exactly one of them hits the target. So let us denote the two persons, the events E1, E2 hitting the target. Okay. Solution. Let E1, E2 B denote that first person, comma, second person respectively hitting the target. Then from the given data, comma, so first person is given in the favor and the second person given against. Okay, P of E1 ratio P of E1 bar is equal to 3 ratio 5. 3:5. And against the second person. So P of E2 bar ratio P of E2 is equal to 3:2, 3:2. This is the data given. After assigning this E1, E2, the first person, second person hitting the target. What is the question? From this, P of E1 according to ratios, 3/8, total share is 8. First E1 share 3, E1 bar share is 5. P of E1 bar is equal to 5/8. And P of E2 bar 3/5, comma, P of E2 is equal to 2/5. First question, probability of both hits the target. This is nothing but, according to set theory, both means intersection, E1 intersection E2. So this type of problem, man woman appearing interview, that and this type of problems are called independently trying. Independently they are hitting the target. Okay, firing once. Okay. So P of, sometimes the word dependent available in the problem, sometimes you only identify the problem, is equal to how much? P of E1 is 3/8 and P of E2 is 2/5. Okay, so 4 3/20. Since E1 comma E2 are independently trying. Next, see. At least one hits the target. That is, according to set theory, this becomes E1 union E2. So, using addition theorem of probability, P of E1 plus P of E2 minus P of E1 intersection E2. Later you calculate from this one and the above data. And the third bit, exactly 1. I am not writing the sentences in detail, short sentences I am writing. Exactly 1 means E1 hits the target, E2 fails to hit the target. If E2 hits the target, then E1 fails to hit the target. So two exclusive events in this, P of E1 intersection E2 bar or E1 bar intersection E2. This means mutual exclusive in this, P of E1 intersection E2 bar plus P of E1 bar E2. So according to independent events, E1 E2 independent means E1 and E2 dash E1 all are independent. Bar means here dash. So that results will help a lot. Independent events note point. Plus P of E1 into E1 bar into P of E2. Later you simplify. Since E1, E2 bar, E1 bar, E2 are also independent. So last example in probability I am giving in this first chapter, second chapter, random variables distributions. One more problem which is asked 2010, 2 marks. A box contains 4 white and 3 red balls. Full stop. In succession, comma, 2 balls are randomly selected and removed from the box. Full stop. Given that the first removed ball is white, comma, the probability that the second removed ball is red is, answer is 1/2. Second chapter is random variables and distributions. So far we have discussed the probability of non-numeric items. Now it is probability of numeric items. That means take a sample space of the random experiment. For each outcome, if we assign a real number, then these assignments are called function. That means we then have a function defined on the sample space. That function is called random function or random variable, random vector. Okay, that is random variable is a function from domain sample space to a part or the whole set of real numbers. The range. Domain is sample space, range is real numbers or part of real numbers. A function from S to R is called random variable or random vector, usually denoted by capital X, capital Y, capital Z, and its values are denoted by small size letters x1, x2, x3, so on, y1, y2, y3, so on, like that. Okay, so it is of two types. Okay, anyhow, you write. A real valued function x, comma, defined on a sample space S of a random experiment that is x is a function from S to R is called random variable or random function It is of two types. A. Discrete random variable, just denoted by d dot r dot v. Rv means random variable, drv means discrete random variable. B. Continuous random variable, denoted by short form CRV. Okay. A RV means random variable which takes a finite, which takes on finite or countably infinite number of values comma is called discrete random variable while one which takes on non-countably or uncountably infinite number of values is called a continuous random variable. That is, it can take all possible values in the given interval or range. Now see, there are two types of random variable: discrete random variable, continuous random variable. A variable which takes on a finite or countably infinite. Finite values are countably infinite. For example, x values 1, 2, 3, 4, 4 values. All these are finite values. That x is a discrete random variable. Suppose x is equal to 0, 1, 2, 3, 4, 5, so on, unended. Okay, that is infinite values, but it is one by one counting. That is also called discrete random variables. For example, take a set like this, set of all x such that minus 1 less than x less than 1. So in this we cannot count the numbers between minus 1 to 1. It is uncountably infinite values. Such type of values are also represented in intervals, open interval, closed interval. This is also called range. Okay, that is called discrete continuous random variable. So based on this, we are dividing into two types of random variables: discrete, continuous. So there are probability distributions, discrete distribution and continuous distributions. Based on this, we can divide distributions into discrete distributions based on a discrete random variable and continuous distributions based on a CRV, continuous random variable. So based on these two discrete and continuous random variables, we have the distributions divided into two cases: discrete distributions and continuous distributions. Based on a discrete random variable, DRV means discrete random variable, CRV means continuous random variable. Examples of discrete distributions are binomial, Poisson, etc. And examples of continuous distributions are normal, uniform, etc. Just introduction only this. So for every outcome on a sample space, we assign a real number. That assignments are called function from sample space to real numbers or part of a real number. That function is denoted by capital X, capital Y, capital Z, and then it is called random variable or random vector or random function. Because of two types of values, discrete values, continuous values, so that discrete random variable DRV, continuous random variable CRV. Based on this, the distributions are also divided into two cases: discrete distributions and continuous distributions. Some of the examples. Okay.